Okay, guys, we're back here again. We're taking a look at another trig equation. Another trig equation. All right. So, um, actually, that's not the one for now. We're going to go down to this guy, number 20, this cotangent expression. Okay. All right, this cotangent expression. Now, a lot of you jumped right on that and saw that right through that was with a suitable substitution, a um, a four-term expression of the order 4u cubed plus 3u squared minus u minus 1, where obviously we're calling u equaling the cotangent. Okay, so if need be, you turn it to that so it looks a little bit more user friendly. That suggests you factoring by grouping. Okay, factoring by grouping, which suggests let's split it down the middle. From the first two, 3u squared comes out, common factor, and then you got u plus um, uh, u plus 1, right? Yeah, okay. And then over here, pull out minus 1, and then again, you got u plus 1. So the expression factors as a polynomial as 3u squared minus 1 times u plus 1 equals 0. So, um, or if you were able to see right through and do that without that u sub, to go right to factoring down here, same order of business. You pull out the common factor from the first two grouping, okay? 3 cotangent squared, and then minus 1. Nonetheless, we come down to the same thing. If we come to this expression now, back substitute our cotangent, we're at this product of these two trigonometric binomials, if you will. Okay, so again, uh, like most any of these problems, we want to get equal as the product of two terms equaling 0, product of three terms, however many terms, and most of them are going to be a product of two terms equaling 0. So implying that a equals 0 and a b equals 0. So that being the case, we can set our 3 cotangent squared x minus 1 equaling 0, which collapses to 3, which collapses rather cotangent of x squared equals 1/3, and from this entry over here, cotangent x equals negative 1. Now, I know we haven't really discussed much on the graphs of cotangent, and the point in fact is we don't really need to in order to resolve these equations, okay? But we will in time, but for now, let's just deal with this, finding its solutions. Cotangent, of course, is probably well, cotangent squared here. Then to take the square root, we get the square root of 1/3, and let's not forget that is a positive and negative because we're taking the square root. We don't want to lose any of our solutions on that. Okay. Um, so then that being said, we get cotangent of x equals plus or minus 1 over root 3, which reverts to the tangent, of course, which is the reciprocal. The cotangent is the reciprocal of the tangent. So that's the same as saying 1 over the tangent, or in fact, tangent is equal to plus or minus root 3. Over here, got cotan x equals negative 1, reciprocating that to 1 over tan equals negative 1, of course, implying the same thing as tan x equaling negative 1. Okay, tan x equaling negative 1, of course, tangent is negative in the second quadrant with a pi over 4 reference, which is the 3 pi over 4. All tangents are only going to have one solution per cycle. And of course, with the tangent, the cycle is pi. Okay, so our set of solutions from this sole description is that x is equal to 3 pi over 4 plus pi k. Now over here, we have to account for the tan of x being both root 3 positive and negative, okay, which is going to give me two hits. The root 3, of course, is a um, pi over 3 reference. The positive is the pi over 3, and the negative is negative pi over 3. You could say, 5 pi over 3. It's the same. It's It's the same order of business, same thing. But you'll see later that this is going to be the preferred way of expressing that solution. So this expression, this number 20, okay, this cubic expression has 3 hits per cycle, okay, which is um, which is at pi over 3, negative pi over 3, and 3 pi over 4. And they're all with the pi k, which means the period's been unadjusted. And this shouldn't be of any surprise since there's no coefficient of x up there. So now let's take a look at that from the graphical perspective to validate that those are the answers. Okay, so we're going to go to Desmos. Here I've okay, going back to Desmos. Here I plotted that expression right up here. Okay, of course, this was set equal to 0, so which is implying the intercepts of the graph are going to be the solutions to my equation. Sure enough, I pick up 3 solutions per cycle. Solutions per cycle. Nice with Desmos, as you can see. Click on it, it tells you. There's my pi over 3. Plus pi k would take me to 4 pi over 3. Minus pi k would take me to negative 2 pi over 3. So that accounts for that. We get the 2 pi over 3. That's right here, as we called it. Okay, and we get the the uh, the pi over 4 expression. Let me make sure that we accounted for that. Yeah, we got the 3 pi over 4 expression. Okay, we got the 3 pi over 4 expression like we from the tan equaling -1, which again, come on back. Here we go. Here's the 3 pi over 4. Okay, or the negative pi over 4. If you, either way we look at it. So we do get that 3 hits per cycle. Now, I know that this expression looked very cubic, and in fact, in solving it, we made it look cubic, okay? And that the graph here looks very cubic. Mindful, it is not cubic graph. This is a cotangent variation, okay? Uh, the cubic, these have asymptotes here periodically, which is not a characteristic feature of cubic graphs. It is a characteristic feature of these cotangent graphs. And the other characteristic of the cotangent or any trigonometric function is the periodic nature, the repeat pattern. You got you got one you got where it hits in one cycle, then you got all the subsequent solutions, all the cycles down the line. Okay, so there's another one um, of your your equation problem solving techniques illustrated for you via Desmos as well as illustrated for you analytically. Okay, so that's when it should mean the most to you when you see it analytically. And graphically and hopefully intuitively. Okay, that's part of the secrets of success in this course, to visualize things analytically, graphically, and intuitively. The 3 words of the day: don't